Number 1. Cartwheel Galaxy. This composite image of the Cartwheel and its companion galaxies was created using Webb's near-infrared camera and mid-infrared instrument, and it displays details that are difficult to discern in the individual photographs. This galaxy was generated as a result of a high-speed collision 400 million years ago. The Cartwheel is made up of 2 rings, one bright inner and one multicolored outer. Both rings spread outward from the collision center like shockwaves. Despite the collision, the vast spiral galaxy that existed before the collision retains much of its features, including its rotating arms. The vivid red streaks seen between the inner and outer rings are the spokes that inspired the name of the Cartwheel Galaxy. These beautiful red hues are created by blazing, hydrocarbon-rich dust, which can be found not just throughout the Cartwheel, but also in the partner spiral galaxy at the top left. MIRI data are tinted red in this near and mid-infrared composite image, while NIRCam data are colored blue, orange, and yellow. There are many individual blue specks among the red swirls of dust, which indicate individual stars or pockets of star development. Number 2. Southern Ring Nebula's gas. Webb's near-infrared camera and mid-infrared instrument obtained this image of the Southern Ring Nebula, which includes compass arrows, a size bar, and a color key for reference. The north and east compass arrows indicate the image's orientation in the sky. The relationship between north and east on the sky is flipped compared to direction arrows on a ground map. The distance traveled by light in 1 Earth year is labeled on the scale bar in light years. 1 light year corresponds to approximately 5.88 trillion miles or 9.46 trillion kilometers. This image's field of view is approximately 0.25 light years across. This graphic depicts invisible near-infrared and mid-infrared light wavelengths that have been converted into visible light colors. The color key indicates which NIRCam and MIRI filters were used to capture light. The visible light color used to represent the infrared light that passes through each filter is represented by the color of the filter name. Number 3. Neptune Wide Field. Webb's near-infrared camera acquired this image of Neptune and its rings and moons, which includes compass arrows and a color key for reference. The north and east compass arrows indicate the image's orientation in the sky. The relationship between north and east in the sky, as viewed from below, is flipped relative to direction arrows on a ground map, as seen from above. This graphic depicts invisible near-infrared light wavelengths that have been converted into visible light colors. The color key indicates which NIRCam filters were used to collect light. The visible light color used to represent the infrared light that passes through each filter is represented by the color of the filter name. Number 4. Titan cloud evolution on Titan between November 4th and November 6th, 2022, as seen by Webb NIRCam and Keck NIRC2. Titan's trailing hemisphere, as seen from Earth and the Sun, rotates from left to right. Cloud A looks to be spinning into view, while Cloud B either dissipates or moves behind Titan's limb. Because clouds do not remain long on Titan or Earth, those seen on November 4 may not be the same as those seen on November 6. The following filters were utilized in the NIRCam image: blue 140M, 1.40 microns, green 450W, 150 microns, red F200W, 1.99 microns, and brightness F210M, 2.09 microns. Red HA1B, 2.06 microns, green KP, 2.12 microns, blue H210, 2.13 microns, were used in the Keck NIRC2 image. Number 5. Interacting Galaxies. VV191 researchers were able to track light emitted by the massive white elliptical galaxy at left into the spiral galaxy at right, and determine the impact of interstellar dust in the spiral galaxy by merging data from NASA's James Webb Space Telescope and NASA's Hubble Space Telescope. This image of galaxy pair VV191 combines Webb's near-infrared light with Hubble's ultraviolet and visible light. Webb's near-infrared data also reveal significantly more detail about the galaxy's longer, extremely dusty spiral arms, which appear to overlap with the central bulge of the bright white elliptical galaxy on the left. Although the 2 foreground galaxies are astronomically close, they are not actively interacting. Don't ignore the beauty in the backdrop. This view of VV191 displays several distant galaxies, as do many other Webb photos. Two patchy spirals to the upper left of the elliptical galaxy, for example, have equal apparent diameters but appear in quite distinct colors. One is probably highly dusty, and the other is quite far away, but researchers need spectra data to figure out which is which. Number 6. Dwarf Galaxy WLM. The James Webb Space Telescope's near-infrared camera recorded a piece of the Dwarf Galaxy Wolf-Landmark Melotte WLM. Webb's extraordinary ability to resolve weak stars outside the Milky Way is on display in this image. Color translation, Géomètre 9. Micron light is blue. 1.5. Micron light is cyan. 2.5. Micron light is yellow. And 4.3 micron light is red. Number 7. Tarantula Nebula. Webb's near-infrared camera captures the Tarantula Nebula star-forming region in a new light in this mosaic image, measuring 340 light-years wide, revealing tens of thousands of previously unseen newborn stars cloaked in cosmic dust. The most active region looks to be glistening with enormous young stars that appear pale blue. Scattered among them are still embedded stars that appear red and have yet to escape from the nebula's dusty cocoon. Because of its unparalleled resolution at near-infrared wavelengths, NIRCam can detect these dust-enshrouded stars. An older star conspicuously displays NIRCam's unique 8 diffraction spikes, an artifact of the telescope's structure, to the upper left of the cluster of young stars and the top of the nebula's cavity. Following this star's top central spike upward, it almost points to a distinct bubble in the cloud. Young stars are blowing this bubble, beginning to carve out their own cavity while still surrounded by dusty material. Astronomers utilized 2 of Webb's spectrographs to investigate this region and determine the chemical composition of the star and its surroundings. This spectral data will tell scientists how old the nebula is and how many generations of star birth it has witnessed. Cooler gas further out from the core region of scorching young stars takes on a rust color, indicating to astronomers that the nebula is rich in complex hydrocarbons. This thick gas is the stuff that stars are made of. As the enormous star's winds sweep away gas and dust, some of it will build up, and with gravity's assistance, form new stars.